In this section, let's cover the architecture that will be used throughout our studies of Deb6x edition. Let's unlock the screen. We have the PNG file, or Portable Network Graphics file, open. So this file covers the topography of our environment. Let's go full screen and discuss the items. So typically we use this sort of topography/topology when studying various operating systems throughout Linux CBT. So, for example, from a layer 4 perspective, the DNS that's shared is linuxcbt.internal, which of course is not routable on the internet, so it's for private usage only. Some other suffixes or top-level domains that are valid include .invalid. We use .internal, which is not routable on the internet. Sometimes we use .external for subsequent domains for DNS, and that's also not routable on the internet. So long as you stay away from, for your internal purposes, routable external domains for which you don't own, you should have no problems whatsoever with respect to layer 4 or name resolution. So this is our layer 4 name. Now, layer 3 wise, we're using an RFC 1918 address of 192.168.75.0/24. So 8 bits are reserved for assigning hosts on our internal network, and the preceding 24 bits are reserved for defining the specific network 192.168.75. We also have another subnet, the 10 subnet. Sometimes we label it 10.0.0 and other times 10.10.10. It's alternated, so currently we have it marked up as 10.10.10, but sometimes we reference it as 10.0.0, or the 10.10.10 will exist and will perhaps create a subinterface or an alias interface on our Debian hosts, which reflects perhaps 10.0.0.0/24 bits, if that's applicable for that configuration. Now, from a layer 2 perspective, we have 2 switches. These are the Catalyst 3550 switches that are interconnected with a GBIC. They service a number of VLANs, but the basic internal VLAN, which is VLAN number 1, is the 192.168.75.0/24 layer 3 internal network. And connected to this internal network are the following hosts that we'll reference from time to time, which include the Debian 5x box, which will upgrade to version 6x. That's Linux CBT build 1, which is a production box for us, which is used to build various ISO images and maintain the source videos that ultimately make it into the production stream. So it's currently running 5x, will be upgraded to 6x. Then also we have, and also this server doubles as a PXE TFTP server, so when we install across the wire, PXE is serviced from here, and then the installation takes place across the internet. So our router, which is up here, services the network DHCP-wise, sending clients to this PXE TFTP server to download the startup code necessary to perform a network installation. Now we also have our Debian 6x instance where we'll be installing using PXE Debian 6x 192.168.75.21. This is the host that will do primarily most of our work on Linux CBT Deb 1. It also belongs to the same suffix of linuxcbt.internal, and it'll run Debian 6x. So we'll install here across the wire, deriving a DHCP address from the router, which will then send the PXE signal to boot from the PXE TFTP server. There's also a Windows 2008 system, 75105. Its name is Linux CBT 2K8. It belongs to the same layer 4 top-level domain, and we can access this system to try out different things from the Windows perspective, such as FileZilla and otherwise, perhaps PuTTY FTP. So internally we've got Windows, 2 Debian instances. One is a production system, the other will become our classroom training system. There's also a Mac OS X system, which is labeled MacBook 2, which serves as a point of interest for us to communicate with from time to time, so we can SSH into it or SSH from it, or run port scans of it or from it, or do other types of connectivity tests, since indeed it's FreeBSD. In the DMZ, we have 2 systems currently. One's a Red Hat Enterprise 6X box located at 10.10.10.2, and its name is Linux CBT RH1, and it's in the same domain, despite the fact that it's in a different layer 3 subnet. So again, it's running Red Hat Enterprise version 6. And next to that system is a SUSE Enterprise 11 box, Linux CBT SUSE 1, which is at 10.10.10.3 in the same second and top level domain Linux CBT.internal running SUSE Enterprise 11. These two systems access the remainder of the network as well as the internet through the common router, the Cisco 1811 router, which functions as a router between the internal, the DMZ, and the internet. It's running 12.4 iOS code, not Apple iOS, but Cisco iOS. It supports IPv6 tunneling, 6-to-4 tunneling. So as a consequence, what you'll see as we study interface configuration is that all of the interfaces for these different Linux systems on the inside, as well as the Windows hosts, are auto-configured with a 6-to-4 address with a 2002 prefix with the 32-bit IPv4 address of the external interface of our router embedded. So we've got 2002, the 32-bit address, the mandatory FFFE, padding out the full address on the network side for a full 128 bits. So this 1811 router is configured for 6-to-4, and it delegates or distributes the 6-to-4 prefix to the different hosts on the various subnets that are connected to the router, including the DMZ, as well as the internal network or the internal VLAN. So this is the hub of the network. We often connect to this router to confirm connectivity from IPv6 v4 perspectives, to confirm layer 2 information such as a MAC address and so on. So again, just as a brief review, layer 4, Linux CBT.internal, we reference quite often. Layer 3, 192.168.75.0/24. Layer 2, it's largely Ethernet. There aren't any other types connected that we'll be looking at, such as wireless or otherwise. So it's Ethernet. And connected to the internal are these systems, connected to the DMZ are these two systems, and we constantly bounce between the systems. Now again, we do the bulk of the work from this particular Debian 6x box named Linux CBT Deb1. From here, we're able to launch connections to all the different systems. For example, when we connect to the Windows 2K8 box, we use utilities like rdesktop to obtain a desktop session on the system using RDP over TCP 3389. When we need to connect to remote shells, say on the Debian 5x, 6x instance, or the Mac OS X instance, or the Red Hat instance, or the SUSE instance, or even the router, we use the SSH client. For a brief moment, we look at the Telnet client to connect to some of these hosts, but we largely use SSH from this system to connect outbound to the other systems. And there are instances where we connect to the remote systems and then connect back to the source system, Debian 1 or Linux CBT Debian 1, to illustrate connectivity in a variety of ways. So this is the architecture. This is the typical architecture that we use for the most part. We'll be using throughout our studies of Linux CBT Deb6x edition.